mechanics and conservation of energy. Okay, well this is, actually we might get 2 lessons done because this one is a very, very easy lesson.
I love easy lessons.
I know you love easy lessons, but they can't all be easy. So I think actually we'll get 2 done because this one is only going to be a few minutes. It's not really a lesson, even though I call it a lesson. It's like a fake lesson. Okay, if you can write this down, conservation of energy. You got that? Good. Right, so we all understand this word energy, like you can see in the picture. Electricity, electrical energy. So what is energy? So, yeah, if something has energy, what does that mean?
The ability to do work.
Yeah, so if something has energy, then what do we mean? So the definition is something has energy if it can do work. So if you can work, then you have energy. So you can write this down, please. Let's just say if it has, I'll fix that later. If it has the ability to do work. Yeah? Okay, you have this? Okay, so it's also measured in joules. No work means no energy. No energy means no work. And the work done is always less than the energy available to do the work. So for example, if I have 1 megajoule of energy, then that means I can do up to 1 megajoule of work. Can I do more? No. So if I have 1 megajoule of energy, I can do up to 1 megajoule of work. So, for example, if my little man here, if he has 200 joules of energy, then he could do maybe 100 joules of work, and then 100 joules of work, and then he's dead. Something like this, okay? So, yes. Often in our problems, all the energy becomes work. Okay? So sometimes you might hear me say work and energy are the same. They're not really the same, but usually they are, because usually all the energy becomes work. There's no energy left. So, okay. There are many types of energy. So, that is, there are many types of things that can do work. So, get ready. We'll have a look at all of them. Okay? Right. So the first type of energy is electrical energy. This can do work, yes? Okay, so you write this down. This is the first type, electrical energy. Types of energy. Okay. Electrical energy. This is a very common form of energy, isn't it? Yeah. Right, next energy form. Magnetic energy, like at the junkyard, you can lift things up. Magnetic energy. So it's the next type. Yeah. Magneto form of energy. You all know magneto, of course. Absolutely.
Yeah.
Right, next form. The most delicious form is chemical energy. This is the only form that tastes good. Yeah. Also the most important for your living. Yes, chemical energy. So food has energy in it, because you can do work when you eat. Okay. So chemical energy. Now the next one is like radiation, radiant energy. It's the energy we get from the sun. It's not quite light, because it's more than light.
It must be thermal or?
Yeah, it's actually more than that. Yeah, it's radiant energy is the energy from the sun.
Solar.
It's like this, but it's more than this, because you know, for example, this energy can hurt your skin.
Like a new.
Yeah. So it's not just light, it's more than light. It's what you get from the sun. We'll look at this in semester 2. It's called radiant energy, or radiation maybe. You know this word? Yeah. This is the same energy in microwave oven.
Yeah.
Is what I was kind of thinking of actually. Maybe I should have done a microwave. Okay, radiant energy. Next. Nuclear energy. You know this one? Yep. Maybe you have this in your home country. Now, the next one you might know from chemistry if you've done it with Lorraine. Have you done this with Lorraine? Ionization energy. So what is ionization?
So with the charge to separate the charges, or when we do something with the charges, there is an energy we need for the atoms.
Keep it simple. Keep it simple. That's what I want to hear. Yeah. So the movement of an electron from one level to another level, or from out of the atom into the atom, there's a change of energy. Yes. Okay, we got this?
Yeah.
Yep, ionization energy. Okay. This is a fun energy, elastic energy.
I almost got expelled because of this energy.
It's a fun form of energy. Elastic energy. Okay. Next one. Alright, so I set them all. I think there's a couple more. Now the next one's interesting. Gravitational energy. So this is the energy from like the planets. The gravity. We've done gravity, haven't we? We've done this word. Yeah. Yeah. And there's definitely another one. So gravitational energy. Next one. Heat energy. Again, an important one. Yep. Heat energy. Next one. Now this one's interesting. Mechanical energy. Like the picture. The energy from the like the machine, just like in the picture, like in a clock, an old clock, you know, where you turn it. Yeah, that's more complicated than that. It's a type of movement energy from a machine. Mechanical energy. Okay, continue. Yeah. Wave energy from the ocean. Yes. Oh, not moved yet. Okay, can you get by there? You did the first time. Alright, you got this one? Yeah. Now the next one is interesting, kinetic energy. That's the energy you have because you're moving. Okay? So, like for example, if you see here, look. If I throw this and throw back, yes, go. No. As it's moving, it has energy. So this movement is called kinetic energy. Energy from moving. Yep. Okay, got that one? Yeah. The next one's interesting, potential energy. So this is like the energy it has because it can do something in the future. Like for example, this rock here, it will fall and do some work as it breaks this rock. So at the moment it has energy inside of it because it can do something in the future. You might know this word from English, potential. Do you know this word in English?
Ability.
Like ability, but it's usually about the future.
Ability to do something.
Yeah, and it's usually about the future. So this can do some work and will do some work in the future. So we say it has potential energy. Okay, and is there any more? I can't remember. Let's see. Yeah. Okay, you got this? Potential energy. Okay. Yeah, so potential energy. So for example, like here, if I have this on the edge, okay, it can do work with a little bit of a push. Then as it falls, it can do work. It has energy stored inside of it. Okay. So this is the most, I think we can say it's the most important rule in physics, for sure. This is the most important rule in physics. This is called the conservation of energy. What it is, it says, energy cannot be created or destroyed, but transformed from one form to another. Most important rule in physics. Okay? Most important rule. So let's see what that means. Okay, so I'll give you an example. So what energy is in the wall there? Electrical energy. And when that electrical energy comes out into my laptop, what energy do I get now?
Light.
I get light. I also get sound. I also get heat. Here I get heat. So this energy, this energy plus this energy will equal that energy. Okay. Another example maybe is if I eat something, it has energy in it. And then when I eat it and the work I do should equal the energy from the food. So the energy doesn't disappear. The energy just changes its form. Okay. Most important idea in physics. Yeah.
The energy and the human.
Yes.
It must disappear because it's like doing.
No. But doesn't disappear, it transfers. So for example, if I eat something, this energy comes in me, and then this energy maybe means I can move something. So then I give this kinetic energy. Yeah,
If you don't eat your food for 10 days, you won't be able to do anything.
that's it. Yeah.
Probably die.
Yeah. Now, even if I don't do anything, if I just sit here, I'm still doing work. What work am I doing? Yeah, I'm breathing,
Yes.
producing heat.
Yes.
Yeah, there's electrical activity. So even if you're not doing anything, your energy is still changing its form, heat and sound and things like this. Okay. So this is the most important idea in physics, and it's one of those questions that would be a good exam question. What is the conservation of energy? So energy cannot be created or destroyed. It just changes its form.
Who made it?
Who would this be? I think this might, I don't know if this was Newton or it was after Newton. Maybe it's Newton actually.
Yeah.
I'm not 100% sure.
I think
Is it Mayer?
Huh?
Mayer.
No. He made the periodic classification. Luther Mayer.
I don't know actually. Anyways, we'll continue with the next lesson. I don't even, is there anything?
Yeah. We have done it.
Let's do this one. Let's do this one. Oh, it was in your presentation, was
Yeah.
it? Who was it?
It is Mayer.
But who is this guy? What else did he do?
Well, the,
Yeah, is this the only thing?
I mean,
The conservation of energy?
Because we covered.
Oh yeah, okay. What's that?
He was busy transferring energy.
What's his first name? His family name is
Yeah.
Mayer. His name doesn't ring a bell. Maybe I have to look it up. Right, if you look at this one, if you stand up and sit down, you've done work. Where has this energy come from? So when you stand up and sit down, where does the energy come from? From food. From food, yeah. Let's say from a chocolate bar you ate. Where did the energy in the chocolate bar come from?
From the sugar.
From the sugar, okay. Where did the energy from the sugar come from?
From the from the cane, sugar cane.
From the plant.
Yeah.
Yeah. Where did the energy from the plant come from?
From the seeds.
From the sun, mostly. Maybe from the water, maybe from the food. Yeah.
Julius Robert Mayer. Robert Mayer.
Julius Robert Mayer.
Discovered the law in 1842.
I feel bad for the dude. I don't know him. Yeah.
The law of conservation of mass was given by Lavoisier, and then this was given by.
I feel bad for these guys. I don't know them. I'm saying it's the most important rule in physics, and I don't know his name. Yeah. I always thought it was Newton. Gets all the credit. Okay. So you get the idea of the energy
Newton's
here.
law of gravitation energy. It's for Newton.
Yes. Oh yeah. Well, I know that one is. Yeah. Don't worry. I know that. Okay. Let's have a look at the next.